9b. We need to write an equation of a plane that goes through the point x1, y1, z1. It's parallel to the xy plane. This is the xy plane. If you want to see the visual, maybe you should think of a plane that is parallel to the xy plane. Now, a vector perpendicular to 1 is k. K is perpendicular to the xy plane. And since the planes are parallel, we can say that k is parallel to our vector, which is going to be 0, 0, 1. This is going to be our A, B, C. The equation of the plane is going to be a x minus 5 plus 0, y minus 3 plus 1, z minus 2 equal to 0. This is 0, and z minus 2 equal to 0. Next, we're going to do part C. Part C, you have to write an equation of a plane, passes through the point 0, 0, 6, which we're going to call them x1, y1, z1, and it's parallel to a line, and the line x equal 1 minus t, y equal 2 plus t, and z equal to 4 minus 2t. Now, a vector parallel to this line, it's going to be negative 1, 1, and negative 2. These are the component of this vector, negative 1, positive 1, and negative 2. In order to write the equation of the plane, this is perpendicular, not parallel. Sorry, it's my mistake. And so we're going to call this vector A, B, C. This vector is perpendicular to this plane that contains that point. If you want to see the visual of it, we have a point in the plane, we have a line perpendicular to the plane. The vector here is parallel to the line, but it's also perpendicular to the plane. So the equation of the plane is going to be negative 1 x minus 0, positive 1, 1 minus 0, minus 2 z minus 6 equal to 0. This will give you negative x plus y minus 2z plus 12 equal to 0. All what I need you to do is make the leading coefficient positive. So that will be x minus y plus 2z minus 12 equal to 0. We wanted to check to see if those two planes are parallel, perpendicular, or neither. I want you to look at the first vector, the equation of the plane. Pick a vector perpendicular to the plane, and that vector is going to be 1, negative 5, negative 1. The second vector, we're going to pick a perpendicular vector to that plane, which is going to be negative 5, negative 2, negative 5. We want to test these two vectors and check to see if they're parallel, perpendicular, or neither. The first thing I want to do the dot product to see if they're perpendicular, orthogonal. 1 times 5 is 5. Negative 5 times negative 2 is 10. 1 times negative 5 is positive 5. That's definitely not going to be 0. They're not orthogonal. Next, we're going to see if they are multiple of each other. Does 1 over 5 equal negative 5 over negative 2? Does it equal negative 1 over negative 5? Even though those two are equal to each other, but they're not equal to the middle one, therefore they're not parallel. So these two planes are neither, neither, whatever. To check to see the angle between those two vectors, first I want you to pick a vector perpendicular to the first plane. 1, 1, negative 1. Then I want to call this vector U. A vector perpendicular to this plane is negative 2, negative 5, and negative 1. So that's 2, negative 5, negative 1, and I'm going to call this one V. We want to find the angle between U and V, and hopefully it will be acute. If not, the angle between two planes has to be acute. U dot V, 1 times 2, 1 times negative 5, and 1 times 1. and so that's going to give you -2. The magnitude of u is going to be the square root of 1 squared plus 1 squared plus 1 squared, which is square root of 3. The magnitude of v is going to be the square root of 4 plus 25 plus 1, square root of 30. The angle between the two planes is going to be theta is equal cosine inverse of -2 divided by square root of 90. And that should give you, if you put your calculator in a degree mode, it should give you an obtuse angle. Subtract this angle from 180, and your angle between the two planes, which is theta, equal to 77.83 degree. It has to be acute. Last but not least is graphing number 12, graphing a plane. First of all, I want you to do the x-intercept when y is 0 and z is 0. In the case this is 0 and this is 0, that's going to be a 4. The y-intercept, the z is 0, the x is 0, and this will be -6. And the z-intercept, this will be 0 and this will be 0, and this will be a 3. So if you go to the first point, 1, 2, 3, 4, that's your x-intercept. -6 is going to go in this direction. It's going to be 1, 2, 3, 4. Oh gosh, okay, hang on. 5, 6. And the z-intercept was 3, so we're going to go up 1, 2, and 3. If you connect those 3, you created a plane in the shape of a triangle. This is the sketch of that plane. Sketching this plane, it's going to be parallel to the x-axis because x is missing. So we have the y-intercept, which will be 0, 5, 0, and the z-intercept, which is 0, 0, and 5. So we want to go to the y-axis, 1, 2, 3, 4, 5. We want to go to the z-axis, 1, 2, 3, 4, 5. We want to connect those to a straight line like this. From each one of those locations, I need you to make a line parallel to the x-axis. This is the x-axis, and we want the plane parallel to it. You do it at any length you wish, and then close it at some point. This plane right here is parallel to the x-axis. Next, we're going to try the last plane, and that plane is x equal to 3. When you graph a plane x equal 3, missing the y and z, this is going to be parallel to the yz plane. And so if you look at the plane, only crosses the x-axis, 1, 2, 3. It's going to parallel to the y, so I need you to make a line parallel to the y. It's parallel to the z, make a line parallel to the z, and then close it at any length you wish. This plane right here is parallel to this plane right here, which is the yz plane. Thank you. Bye-bye.